Hi everyone, it's Jason here and welcome again to our lesson on EE102 Electrical Circuits 2. Now that we have discussed the basic components of sinusoidal signals, we are now ready to discuss another interesting topic in electrical circuits, which is phasor. A sinusoidal current or voltage at a specified frequency has two parameters, namely amplitude and phase angle. For example, assume the sinusoidal form of current I of t is equal to Im cosine omega t plus phi. If we are going to get the complex form equivalent for this signal, we can have Im e to the power of j omega t plus phi. We can then observe that all throughout the calculation of voltage and current, it will contain the same factor e to the power of j omega t, which implies the same information over and over again. We can then omit this factor, given that we know the value of our radiant frequency, or omega. By doing so, we can then rewrite our equation Im e to the power of j phi. This is also true for voltage. Say we have a voltage equation V of t is equal to Vm cosine omega t. We can then write it into this form, Vm angle 0 degree. Moreover, if we have an equation I of t is equal to Im cosine omega t plus phi, this will become Im angle phi. This complex representation is then called phasor. Now, let's revisit the processes that we have discussed so far in transforming time domain to frequency domain. If we have an equation I of t is equal to Im cosine omega t plus phi, we then rewrite it to I of t is equal to Re, or the real part of Im, e to the power of j omega t plus phi. From this, we can now translate it to frequency domain by transforming into phasor I, which is equal to Im e to the power of j phi. Lastly, we can have the final frequency form of phasor I is equal to Im angle phi. Now that we have learned the basic concepts of phasor, let's do some examples. Transform each of the following functions of time into phasor form. Negative 5 sine 500t minus 110 degrees. In this problem, notice that the given has negative amplitude and is in sine format. So, the first step would be transform it to positive cosine format. How are we going to do that? Well, we just have to add 90 degrees to its phase angle. Thus, we have 5 cosine 580t minus 110 plus 90 degrees is equal to 5 cosine 500t minus 20 degrees. Applying the concept that we have learned in this lesson, we can then say that the phasor format for this problem would be 5 angle negative 20 degrees. Before ending this lesson, let's solve another example. 3 cosine 600t minus 5 sine 600t plus 110 degrees. Again, we need to convert the given to cosine function with positive amplitude. 3 cosine 600t plus 5 cosine 600t plus 110 plus 90 degrees. We have here 3 angle 0 plus 5 angle 200 degrees. So, applying the basic addition of phasor, you can now have your answer 2.41 angle negative 134.8 degrees. So that's the basic of phasor.